Okay, perpendicular bisector, section 5.2. Perpendicular bisector is a segment, ray, line, or plane that is perpendicular to a segment at its midpoint. A triangle will have 3 perpendicular bisectors. So a perpendicular bisector is a segment, ray, line, or plane that is perpendicular to a segment at its midpoint. And the triangle will have 3 perpendicular bisectors because each side of the triangle has a perpendicular bisector. So if I label this triangle A, B, C, the purple line here is the perpendicular bisector to AC. The blue line is the perpendicular bisector to BC. And the green line is the perpendicular bisector to AB. If I were to label this point P, what would point P be called? Andy. That would be the circumcenter. That's where the 3 perpendicular bisectors intersect. Equidistant. This is when a point is the same distance between 2 figures. This is when a point is the same distance between 2 figures. Going to the next proof. It says coordinate. We're not going to do it as a coordinate proof. We're going to do a 2-column. So keep the picture. Just draw your 2 columns in there. Now, all of the markings that you have on your picture really shouldn't be there yet. So we're given here that CP is a perpendicular bisector to AB. And we want to prove that CA equals CB. So looking at this. Looking at the given, what can you tell me? What's the next step? Keegan. All right, never minding everything there. Christina. Okay. Nicole. Of. Good. Justification. Good. Remember, CP is a perpendicular bisector to AB. A perpendicular bisector creates a midpoint. So P is the midpoint of AB. Definition, perpendicular bisector. P is the midpoint of AB. Lauren, what can you tell me? Good. Why? Good. Brendan. Good. CP is congruent to CP reflexive. Next, Max. Why? Nah, definite perpendicular line does not say anything about making angles congruent. Andy. What other angle is? Why? Perpendicular lines makes our angles right angles. So CPB and CPA are right angles. Now that they're right angles, what can we say? Brendan, do you have a question? You can put them together, that's fine. Justification. Good. No, because we have a theorem that says all right angles are congruent. So all we need to do is get them to be right angles, then we can say they're congruent. If you wanted to do that, you could. It would just add 3 extra steps. If you forgot the theorem, it would just add 3 steps to the proof. What? What? They're... Where's the chain, though? Yeah, all we have is an and here. Because they're right angles, then we can say they're congruent. Okay. So what do we have now? Do we have Edmund? Give me the triangles, please. Good. Triangle CAP is congruent to triangle CBP. And that's side angle side. Danielle, now that the triangles are congruent, what can you tell me? Good. CA is congruent to CB. What's that justification, Danielle? CP, C, T, C. CP, C, T, C. Corresponding parts of congruent triangles are congruent. And now that they're congruent, what can you tell me? Now that they're congruent, what can you tell me, Dan? That they're equal, very good. So CA equals CB. And that's definition of congruent segments. And we're done. Yes. Third angles theorem, not sides. Third angles theorem. Okay, when we look at this proof we just completed, point C, where does it fall? Point C, where does it fall? Dan. Okay, it is the vertex of the triangle, very good, but it falls on what? What type of line does point C fall on? What type of line does point C fall on? Tyler? No, not an angle bisector. Christina? A perpendicular bisector. CP is a perpendicular bisector. So point C falls on the perpendicular bisector. What did we just prove about a point that falls on the perpendicular bisector? What did we just prove about a point that falls on a perpendicular bisector? Andy, did we prove it to be an angle bisector? No. We proved it to be what? Yeah. The same distance between the two what? What are A and B? What's points A and B? Points A and B are angles? No. Here, let me do this. Let me get rid of this. We proved point C to be what? Edmund? From between what 2 points? A and B. We proved point C to be equidistant from A and B. That is theorem 5.2. Perpendicular bisector theorem. It says in a plane, if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. Yes, Dan. Good question. That was actually going to be my next question, which I was going to have to ask for tomorrow. Yes, Brendan. No. Dan, keep that question for tomorrow, because it'll be answered tomorrow. Dan's question is, why do we really care about this? How's it going to help us? Why does it matter? We'll answer that tomorrow. Okay, yeah. A perpendicular bisector creates a midpoint, but any point that falls on the perpendicular bisector is equidistant between the two endpoints. So what this theorem is saying is that if I have point D on here, what do we know about point D? It falls on the perpendicular bisector, so what do we know about it now? Max? Very good. So we know that DA equals DB. That's what we know. Any point that falls on this perpendicular bisector, if I put an E here, it's equidistant from A and B. If I put F, it's also equidistant. Point P is a midpoint, but it's also equidistant. Does that make sense? Okay, your assignment for tonight, 5.1c. 5.1c, numbers 1 through 9. 5.1c, numbers 1 through 9.